So let's use all of this to make some inferences from the histogram. There are a few things that we can talk about. Using this visual representation, where is the center of our data? So we can say that the center of our data, where the majority of our data points lie, are between 3 and 9%. So most countries have an unemployment rate between B/W between 3 and 9%. This makes sense. Typically, when we're talking about an unemployment rate, it's a very small rate. You don't really want your country to have a very large employment rate. Between 27 and 30% is a very large unemployment rate, which means that there's probably something very wrong going on in your country to the point where most of your people are not working, or a large chunk of your people are not working. So most countries would consider even between 6 and 9% to be a pretty detrimental percentage. During COVID, a lot of countries are starting to post what their unemployment rate was, and it was from the context of the situation, how you could hear people saying it. I'm sure you could derive like, oh, I'm supposed to be shocked that this is so high. But it was really numbers like 10%, 12%. I think we got up to like 25% in the United States for a while there, and that is very high because most countries have an unemployment rate that's along or around this range. So number one, visual representation of where the center of the data is. We could then draw from this that this is about where most of our data lies. It is fairly clustered. And it is skewed to the right because the tail is on the right. Which means that most of our data is towards the smaller numbers. And again, talking about the fact that we want our numbers to be small here, and that's good. All right, so histograms are pretty straightforward. I'm assuming most of you have seen them at some point. We have a few more graphs that represent our tables, and they will look like this. The histogram that we just showed is a histogram of frequency. We can also have a relative frequency. Histogram. So we're going to take our histogram from above and turn it into a relative frequency. So a relative frequency histogram, remember that relative frequency is our percent. The only way you know the difference between frequency and relative frequency histograms is you have to look at the labeling of your axes. So if I'm going to go through and do the same ranges that I did before, so there we go. This is still an unemployment rate. However, the y-axis here will be labeled as a percent. Realize above our y-axis was labeled as frequency. So this means how many specific instances occurred within this range, whereas in this histogram below, it's going to give us a bar graph, just like it did above, but then these bars are going to represent what percentage of the total population fell under this graph. And we're going to notice that it looks very similar. It just depends on how your axes are labeled. So I then need to take my frequency that I had for my previous page and turn it into a relative frequency. We're also going to want cumulative frequency later, so I'm going to do also cumulative frequency. So on our previous page, we had a frequency of 9, 44, 26, 14, 8, 3, 3, 2, 0, 1. And those were all of our frequencies. And it was out of a total of 110. So what I would like for you to then do is take and find the relative frequency. I'll remind you, relative frequency is when you take frequency and divide by your total. So if I were to find the relative frequency for 9, I would do 9 divided by 110, which is 8%. I would like for you to go ahead and finish this up and find the relative frequencies. So press pause and then come back. Okay, so there's our relative frequency. And so what we do is now we take these numbers and graph them between the range. So I have my largest percentage is 40. I'm going to go through and mark my percentages for all of these guys. So between 0 and 3 is going to be 8%. This is 10, 20, 30, 40%. So 8 is going to be about right here. You do not have to put the number in the middle. That's just something I wanted to do up above. So then between 3 and 6 is going to be 40%. And go ahead and finish filling this out. Press pause, finish it, come back. Okay, so here is our relative frequency histogram, and you can compare it to the histogram that we made above, and it looks exactly the same. The only difference here, all of the visual aspects that we just listed above are still the same. You can still figure out where the clustering of data happens. You can still figure out if it's skewed. You can figure out where the center of the data is and why, and make inferences from that, extrapolate information from that. The only difference here is how you then phrase the information that you pulled, right? So from the histogram above, you can say, well, about 44 of the participating countries had an unemployment rate between 3 and 6%. Whereas below here, you can say 40% of the population tested or data gathered has an unemployment rate between 3 and 6%. So you're talking about the same amount of data, but just in a different way. And so that's what you need to be wary of, is that when you then start to extrapolate information from this graph, is that you're talking about the percentage of your sample, whereas above you're talking about specific data points from your sample. Okay, we're going to do cumulative frequency because on our next page, we're going to talk about cumulative frequency. So while we're here, let's just fill it out. So we've got 9, and then we add 44 to get 53, add 26 to get 79, 93, 101, 104, 107, 109, 109, and then 110. So that's our cumulative frequency. Remember, we're just adding these in. I did it quickly because I can. Don't worry if you didn't do it quickly. All right. So the next two types of graphs, next two types of visual representations of our frequency tables are actually graphs as opposed to histograms. So we can have a frequency graph and a cumulative frequency graph. So it's pretty much exactly what the histogram is, except for now we're just going to represent it as points. So if I were to build my X and Y axis, I'm still going to go in jumps by 3 because that's where my data is gathered and grouped into. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So I'm going by steps of 3 because at the end of 3 here is where I'm going to put my amount of data that I have between 0 and 3. So for instance, the amount of data for frequency that I have between 0 and 3 for not percentage, right? Is 9. So I need to go all the way up to 44 is my highest number of frequency. So I need to make sure I go up to that. We have 1, 2, 3, 4, 5, 6, 7, 8, which means I'm going to jump by units of 10. Me doing this very quickly and organizing my units and on my axis just comes from years of practice of choosing something and then being like, oh, I couldn't represent all of the numbers that I wanted to, and then having to go back and erase. So it's just me using all of that history. So if it takes you a little bit longer to figure that out, if you're like, how did you figure it out? I'm just choosing a number, trying it out. If the units of jump of the I'm totally blanking on what it's called, but the jumps that I do, if it doesn't work, then change it, erase it, go back. So you can include your highest number that you need to get up to. I need to get up to 44, so it goes there. If I went up by units of 5, I wouldn't be able to fit it in. Okay, between 0 and 3, we have 9 points, 9 data points. So at 3, I'm going to put a dot where I think 9 goes. Again, we should make sure to label our axes. This is unemployment rate, and this guy is frequency, no longer percent. This is actual numbers of reference for our data. Between 3 and 6, we had 44 data points. And then we have 26 between 6 and 9. So I'm going to go, again, I'm like, okay, halfway is 25. So I'm going to go just a little bit above that to get to be 26. Go ahead and put in the rest of your dots as I am. I'm not going to say it out loud, but you can check what I'm doing. I'm going to go through then and connect them all one at a time with a line. We're not going to make a curve here because we don't really know the pattern. We're not assuming that there's like some asymptote. We also don't have half of a person to reference. So we don't want to have a curve that implies that we could do like a frequency of 1.5 people fell under this category, right? It's whole numbers. So that's why we do straight lines as well. So this is your frequency graph. Comparing it to your histogram that we drew, it kind of shows you the same tendency of data. It shows you where the bulk of the information is, that it tends to taper off, starts off pretty small, gets really big, and then starts to taper off as you go out. So it still shows you that data is just in a different way. All right. Cumulative frequency then is doing that exact same thing, but now we're going to take our cumulative frequency numbers and add them all or put them in the graph. So this means that instead of having our maximum value here be at 44, now our maximum value that we have to have on that y-axis needs to be all the way up to 110. That's the largest number that's going to happen on that y-axis. So that's what we need to keep in mind. We're still going to go by units of 3 because that's what our range is for each of our steps.